Good morning, plant breeders, plant scientists all over the world. Hey, this is David Benson with Cornhusker Hybrids LLC in Lincoln, Nebraska, where our trademark and mantra is success starts with a seed. No truer words have ever been spoken in this business. Today, we're going to keep driving on with our plant breeding commandment series. This is plant breeding commandment number 7. I have no idea where I'm going to stop at, but I've had 7 things to talk about so far, so I'm going to stay with it. The thing today is just going to quick the genetic gain equation, the most misunderstood, probably the most important equation in the world, as you can project what you can produce and how fast you can produce it, and whether you're making progress or not. You can do it from various components and other ways. But anyhow, it's probably the most misunderstood, misinterpreted, and hardest to understand variable of all of the variables, because just exactly what is genotype by environment interaction? Well, in the simplest way, again, I'm just going to quick put the little formula up here so you can see it, so you can think about it, where your genetic gain is equal to your selection differential times your parental constant, dependent on your method of breeding, and the additive genetic variance, all over the year effect, or the years, number of years in this case, which contains all the year effects as well as embedded in it, but over the standard deviation of the phenotypic variance. So, so what you get is your error variance divided by reps environments, your genotype by environment interaction divided by environments, and your sigma squared G, and you really got to square in. All we're going to talk about today is genotype by environment interaction. And we're going to keep it very simple and basic, because that's really what it is until we all make it complicated. So, as far as what I'm talking about today, I just give Walt Fair back in the day a shout out for the book Principles of Cultivar Development. I don't know if students still read it or if they even know what the genetic gain equation is, but they should read it and they should know, because it really makes it easy to understand. And like I said, it's the most important formula in the world. You want to get to it if we eat off it and how we eat off it, and we can interpret that. So back in the day, that was Agronomy 521. And it's one of those classes that you survive or thrive, and I did all right in. So quickly, just to keep it real simple, and this is really simple, maybe it's a little cluttered, maybe it's not. But we talk by genotype by environment interaction, and we simplify it down to two varieties or cultivars and 2 environments. It's simply a change of magnitude in between those 2 cultivars and those 2 environments, which is most of your genotype by environment interaction is change of magnitude, you hope. When you see changes of rank, then that's a more serious thing. You got to really investigate and wonder why. Normally, it's some kind of a biotic factor, or it's a storm. It's a biotic factor or abiotic factor. It's either a storm or something like that, or some interaction there, or it's disease, insects, molds, etc. But things that happen while you're growing cause that change of rank. But you're going to have those. This is 2 cultivars, 2 environments. So most of you may have 60 cultivars, 10 environments, 30 cultivars, 100 environments. Whatever you have, your G by E is a combination of all those, and you normally get all these dots on, and then a regression line that kind of explains it. But you look at a lot of the things now, and they have hundreds of dots on scatter plots, and then a regression line. But that's literally hundreds of genotypes, and you can plot out each one of them if you want to. But this is the simplistic view of what happens. You find 2 cultivars in 2 environments, and they're not going to be the same in both environments, no matter what, I guarantee you. It just will never happen. Even if you're testing the same hybrid, it won't be the same. That's the laws of genetics. So that's the basics of what we deal with every day, going back to the old equation. So again, what is genotype by environment interaction? Well, it's probably what keeps us breeders employed. I mean, if it wasn't for it, we could just produce all your materials in one place, test them anywhere in the world, and they would be the same. And wouldn't that be boring? We'd only need about 10 plant breeders and everybody else could do something else. That's not what happens, and and there's a lot of genotype environment interaction in some crops. There's a lot more than others, and it depends on where you're growing them at and what conditions you're growing them on. And so essentially the factors that contribute to genotype by environment interaction are essentially all of them, or everything or anything you can think of is going to contribute to it. I mean, there's literally hundreds or thousands of variables that you can look at that goes in that if you want to get serious enough. And just for purposes of this talk, I'm just going to talk about a few, and I'm just going to talk about them as abiotic or non-living, or biotic or living, and hopefully I've got that right. And your abiotic things are, many, your soil type, your terrain, the drainage, the location itself, the GPS coordinates of the location, the latitude, longitude, the elevation, all of those factors enter in when you start. And I've even included whether you're in the northern or the southern hemisphere, because I literally, even myself, a small guy, I have materials in the northern and southern hemisphere and in much different places within those hemispheres of latitude, longitude, and particularly elevation. They're all important, but elevation can be extremely important, whether you're at sea level or whether you're up a mountainside, because then it affects all the other weather variables. As far as weather, you got droughts, you got floods, you got winds, you got hails, you got high temperatures, you got freezing temperatures. You have all of those things mixed together in a week sometimes, depending where you are. And the weather is the one thing that's totally random and unpredictable. And you really you don't know. Even if people think they know, they don't know. It's hard to predict. And so your biotic factors are essentially the living things like diseases, whether they're fungal, bacterial, whatever other mode they might be, whether they're insects, what type of insects, what life cycle of insects, how the weather interacts with the insects, and all those other things, but they're the biotic things. And you have leps, lepidopterans, coleopterans, dipterans, and others. And right now you can think of one that's just ravaging the world, and that's fall armyworm. And it essentially has no genetic resistance that anybody really knows about, that they can prove over and over. So we're really out there either with pesticides or some type of biocontrol, which normally doesn't work, unfortunately, or GM crops, which will take care of it in many instances, but a lot of the world doesn't like, so that's where you are. And these diseases and insects, their timing on the crop development depends on whether it's the crop, the leaves, the ears, the roots, or it's the seed that gets attacked, so that depends. But the one thing, and I'm going to close about genotype by interaction, I'll really keep this simple today and short. But I really want you to think about this, because we're going to come back to this. And the thing is that when you plant variety A in field B on day C under the conditions of that day D, which could be hundreds of conditions, that is a unique event that can never ever be replicated. You cannot replicate that event. And if you don't think the day makes a difference when you plant, if you're planting over a month, the day determines everything, because how the weather at an individual location affects the crop goes back to the days from planting. Simple as can be. So when you think about genotype by environment interaction, it's not only the environment, it's the genotypes as well. And that environment is not just the physical land, it is the weather that you get, the summation of the weather that you get while that crop is growing, and how it affects each individual cultivar genotype variety because it's not going to affect them all the same. And us wonderkin breeders who think we're so brilliant do not select the winners. The environment does. The way that genotype interacts with that environment or a series of environments is why it gets selected and others don't. So I'll leave that with you today. We're going to come back to genotype by environment interaction again and again because we only grazed the surface today. And it's the most important interaction, I'd say, in plant breeding, and the most difficult to understand and the most difficult to take advantage of. So this is David Benson in Lincoln, Nebraska with Cornhusker Hybrids LLC, wishing you the best today, whether you're pollinating, whether you're harvesting, whether you're planting, whether you're in between. You got the greatest job in the world. You can fail 99.9% of the time, and they will still build a monument to you if you hit something big on the 0.1. So have a great day. We'll talk to you soon.